Okay, so what I want to do is I want to prove the following. This is called a uniqueness statement or uniqueness theorem or uniqueness proof. But what I want to do is I want to prove that for all non-zero real numbers x, there exists a unique value y such that x times y is equal to 1. So uniqueness proofs have two components. First is that you have to prove that such an object exists. If there is no object such that x times y equals 1, then you can't talk about uniqueness or not. So essentially you have to show that there's at least one object that fits that bill. And then you have to show uniqueness, meaning that there's at most one object. And then once you have those two together, you get uniqueness. There must be exactly one object with this property. And so I like to start with this one. So let's prove that for all non-zero real numbers x, there's a unique multiplicative inverse. In other words, there's a unique real number y such that x times y equals 1. So let me just make clear that I want there to be a unique real number y. Okay, and so first we have to show existence. And so first, just notice that of course we have x times 1 over x equals 1. So we could take y to be 1 over x. Okay, that's a solution. And then the second step is to prove that there's no other solutions. This theorem, by the way, is not a particularly mind-blowing theorem. It's just meant because it's kind of a very simple theorem that shows you how this uniqueness works. So first you show existence, which we just did. Next we need to show uniqueness. To establish uniqueness, what we're going to do is we're going to assume that there's two values. So assume that x times y equals 1 and x times z equals 1. Okay, for some values y and z. Okay, and then our goal is to show that actually if that's the case, then y and z have to be equal, and that shows that there's only one value with a property, right? If we assume that there's two or more values, but they all have to be the same, then there's really only one value with that property. So if x times y and x times z are both equal to 1, then they're both equal to each other by the transitivity of equality, because equality is an equivalence relation. So we can conclude that x times y equals x times z. And from there, we can take 1 over x times x times y and 1 over x times z. And basically, we're taking the equation from before and then multiplying by 1 over x. And from this, it follows, okay, so from which we can see that y must be equal to z. Okay, so that gives us uniqueness. So again, just to recap, we showed existence, and then once we had existence, we showed uniqueness. Okay, and that together is enough to show that this object is unique.